Don't do it, boy.
Dude.
Don't do it, boy.
Every time someone's talking to bell rings, I always like imagine it as like the cuss bleeping. Like someone gets bleeped out on like a TV show. It's like, hey, I'll be getting on there with all that potty mouth.
Good afternoon, ladies and gentlemen. How are we doing today?
We're not going outside, are we?
What's that?
We're not going outside.
For what?
The eclipse.
You'll be around in the next 20 years when it comes around again.
Great. Oh,
So
I might die tomorrow.
see, if you wanted to go outside for the eclipse, you take Earth and Space Science.
I knew you were going to say that.
Which is a class that is going outside today. We could go outside, but we couldn't look at it.
I have the glasses.
You have the glasses? Really? Were you outside last hour?
No,
Why'd you get the glasses then?
because my mom got them for me.
Oh, okay.
Yeah.
Are they NASA approved?
Yes.
Okay, good. Good. Well, keep a hang on to it because 20 years from now we'll be doing it all again. All again, ladies and gentlemen.
You don't know that, Mr. Bradley. I could die tomorrow.
Yeah,
I don't
we
recommend it.
We could get killed in car crashes. We're teenagers. Teenagers are the most likely people to get killed in a car crash.
Because you drive terribly.
No, we're just new and we don't know what we're doing. As someone who drives right now, I just started driving. Like, I almost got hit yesterday. Though that time it wasn't my fault though.
Famous last words. It wasn't my fault.
It wasn't though. That guy came out of nowhere on the right, and I was like, I had my blinker on and everything.
You know, nowhere is always to the right.
I'm scared.
No, my biggest question is someone who's about to go straight.
I'm trying to carry you.
Mine don't. That's what I had. That's how I almost got hit yesterday. Because the guy in front of me put on his blinker for a second, so I was gonna go around him. And then this guy randomly, just like I went to go check my blind spot, and then he's just boom,
like
hitting me.
I
I'm
don't think
like,
that much about it.
where did you come from? You were not behind me 2
minutes.
minutes ago. You must have sped to catch up to me
Want to play the game?
because you were not there 2 minutes ago. Okay,
2 minutes ago.
I'm just giving it approximate.
I think we're
Being
the good
generous.
drivers. I think we're the good drivers and everyone does.
Yeah.
Actually, statistically, teenagers are the worst drivers and boys are worse than girls.
Yeah. That is scientific.
So.
No, it's scientific fact.
Not scientific fact, it is statistical fact.
Statistical. There we go.
There's nothing scientific about it. You guys are bad drivers, not because of science's fault.
Yeah, we're just.
The amount of times my boyfriend has almost crashed.
My boyfriend's actually a really good driver.
Luckily, almost crashing doesn't count
My boyfriend's pretty good.
because you didn't crash. There's either crashing or there's no crashing.
Yeah.
That was on the ice. We headed to we could just got his car and it had snow tires. It had like good brakes and stuff for the wheels because there's snow tires.
She's I know score face.
He trusted too much in them and it's and it hit into the back of the car and it left a hole in it. It was just the plastics, everything.
My boyfriend did a similar thing, but in my driveway, there's like a street that like is like parallel with my driveway. There's a couple houses in between it, and there was this guy that was turning onto our street. So in order so we could get out of the driving lot real quick, that person they didn't even stop for that turn. Like they were just flying around the corner. So my boyfriend was just gonna try to back out really quick and then get to the other side of the street so that guy could go by so he could at least get out of the driveway. And then when he backed out, got to the other side of the street, he backed straight up into one of our really mean neighbors' cars. But of course it was
All right, ladies and gentlemen, before we get going today, I do have a question for you. If you could have dinner with anyone, alive or dead, any famous person, whom would it be? Nadia, grab your periodic table and a pencil, please. Possibly a calculator.
Oh, yeah. No, it's pretty easy. It's pretty easy. You got it. Would you agree? Yeah. Yeah. See, it was pretty easy. I'm gonna break. regularly.
Yes, you do.
Oh, okay. I
That's
can
a
see
game.
that.
They're all iPhone over there, I think.
So one day I can bring it.
Do you have a calculator and a pencil?
I always feel bad because I'm not a person who every time someone asks me for a I'm sorry. What's so burnt? Because I think we're doing a lab too. Oh, yeah. We are doing a lab. Look at you, being all smart. Predicting the future. No, I think I just got the notification.
I got you.
I got one.
Oh, okay.
It's like something
Does anyone want a Mandarin?
lab. Imagine.
I'll be
Oh, okay.
on sleep for like 5.
Yeah. I can't even feel it, so I got big nails on it. You can't
Someone
do
gave
anything.
it to me, and I don't like them. And they told me that I couldn't give it back, so I had no idea what to do with it.
You know how it is?
Thanks for your good.
Thank you.
It's a joke, right?
It like half completely took.
Yeah.
So it's just like, he's like, oh, you think I'm like,
All right, ladies and gentlemen, so if you could have a dinner with any person, alive or dead, who would it be?
Hard question.
Okay, well, give me an easy answer.
I can choose. Who would I have?
Like,
You can always choose. You may not want to choose, but you
Do
can
they have
always
to be
choose.
real?
Yes.
Okay.
They do have to be real. They don't have to be alive, but they do have to be real. What famous non-real person?
I was gonna say Shaggy and
No.
Scooby, because I want to see if I can out eat him.
Hey, Mr. Bird.
no, stop. I don't know what you're talking
Who wouldn't?
I wouldn't, but okay.
about.
I mean, and come on, they always get like the most food. You have the most variety.
Okay.
It would be fun.
Wasn't thinking that way. So, who would your living or dead person be?
I'm not sure on that one.
that's my issue there.
Jeremiah's
No.
First of all, speak for yourself, not for
Alright,
somebody else.
Okay. Might be Kevin Durant.
Okay. Jeremiah?
Probably
Did he?
LeBron. Yeah, LeBron.
Okay.
Did he?
Okay.
Yeah, LeBron.
Jace?
Robert
You know, like his name before you.
You would be an interesting one. Nope. Nope.
Look, brother, he up in
Sabrina?
I don't know. We do look at
He was cool right now.
Okay. Alright. Jax?
There's somebody like I don't know, maybe like Iron Maiden or something like that, one of them bands or something like that. That'd be kind of cool.
Okay.
Hear what they gotta say, you know.
Fair enough. Fair enough. Yep. Savannah? You don't know? Nobody? You're okay not meeting anybody famous? Okay. Earlier today I said I would probably pick Michael Jordan.
How come? Just out of curiosity.
Because I was a big fan of the Bulls during the 90s. Probably the greatest player ever to play the game of basketball, so I would probably go with him. I don't know. I maybe it would be cool to see to have dinner with Isaac Newton
Yeah,
or
maybe
with
the dunk on him.
Albert Einstein. Isaac Newton?
No.
I don't think he was a good basketball player.
It's my LeBron. I mean,
Michael Jordan.
what the Jordan? Very
I
good
wonder
to
if he
dunk.
could still dunk at his age.
I don't know. He probably could throw down a little one.
He's
hand.
got to be in his 60s, I would say.
He might be able to throw down a little one hand, you know?
So, who knows?
One nice rim grader.
Who knows? Who knows? I don't know.
Like my boy Jeremiah.
And I tried to make it a famous person so that you couldn't say like a
Can you
relative.
imagine?
So.
Yeah, I have
That would get there would be a food fight.
All right, ladies and gentlemen, here's what you need to do. You need to partner up with somebody who you're going to do today's lab with. Then you need to come up and you need to get one of these, and one of these, and take them back to you and your partner who you will be sitting next to. So figure out who you're working with, get with them, come and grab everything.
All right. Since Ken isn't here, he rolled his ankle on him. Ooh, yeah, what a silly boy. Not supposed to roll your ankles. You have to kind of keep them straight.
Thank you.
Connecting this.
You only need
At least
one.
in my experience.
You only need one of each.
I've only sprained.
You think go back to there?
No, not yet. In a few minutes, yes, we will be going back there. But for now, I need you to get your computers out. I need, Sabrina, don't forget one of these. And one of those. And then you can go sit by Savannah, please, so that we can get you guys going. All right. Today, ladies and gentlemen, we are going to do a lab on what is called Boyle's Law. Now, all along in this unit, we have been talking about the fact that there are 4 factors that affect the gas. What is one of them? Pressure. We use a capital P to represent that. All right, somebody give me another. What? Temperature. Okay, what else?
Amount of gas.
The amount of gas.
Isn't that like more the
We use a lowercase n for that one, ladies and gentlemen, because we can't use a capital A, represents ampere. We cannot use a capital N, it represents Newton, so they went with a small lowercase n for number of moles. What was the last variable? Volume. Okay, so take a look at the equipment you got. What's one of the variables we're going to be working with today?
pressure?
Take a look at the equipment you got.
Pressure.
Why?
Because we have to measure how much pressure is going in and out.
Okay, how do you know that though?
Well, when you plug it in, obviously on the graph, or you use this.
Well, this could actually change a bunch of things. But if you look on the front of this where it says gas pressure sensor, we're probably measuring pressure today. Okay? Probably measuring pressure today. That's what I was hoping you would go with. Okay, now, the one of you who has the computer that's going to use it to collect data, you need to go and you need to open up the Vernier Graphical Analysis program or app. So down in the lower left-hand corner, if you click on that O that's in the corner, that start button, you can then find this app that looks like this, that has the red and black dotted line, the red solid, the black dotted, and it's Vernier Graphical Analysis. Please turn that on. You need your computers out, everybody, because you're going to have to put your data into the lab, whether you are working with your partner or on your own. So, ladies and gentlemen, you start this app up.
Is that Mrs. Brown?
Now, no, just some random lady who I was sitting next to at an airport and took a picture with. Yes, that is my wife.
Well, I was just
I'm kidding.
I've never seen her before. Is she a teacher too?
Yes. Okay. So this is called a Go link, ladies and gentlemen. This allows the probe to talk to your computer. So there's only one way to plug the probe into the Go link, ladies and gentlemen. So plug it in. Okay. It only goes in one way. If you try to put it in the other way, it won't go, and then you got to flip it around. And then it has a USB port that you can then plug into your computer. Okay? Now, do not hook anything up to this yet. Okay? Do not hook anything up to this yet. What I need to know from you, ladies and gentlemen, in just a minute, is when your graphical analysis came up, if you have your pressure probe plugged into your Go link, and that is plugged into your computer, 2 things should happen. Number 1, on the y-axis, it should be reading pressure. Okay? If it doesn't say pressure, if it just says X and Y, it's not detecting your probe I need to come and I need to help your group. Also down here, ladies and gentlemen, it should say pressure and it should have a number by it, and it should be probably anywhere from 97 to 101 or somewhere in there. So those who have the probe plugged into their computer, does yours look this way? Yes, you got pressure on this axis?
Pressure, time, and then 98.
Jax, you're okay? Savannah? Good. Now I need those of you who have this up to do something. The other three, if you could go into Google Classroom and open up the Boyle's Law Lab that is assigned for today, that's what I need you to do right away. Now, for those of you who have this screen up, we need to change some settings. So down here in this lower corner, lower left-hand corner, where it says mode, time-based, guys, click on the button down here that says mode, time-based, and it will bring up this menu. Okay? Lakavian, you have this plugged into your computer, right?
Yeah.
Okay, did you do this?
Yeah. No.
Okay.
I was trying to fix the charger.
Don't worry about the charger for him. Because if you fall behind here, then I'm going to have to re-explain it to you again in a few minutes. We can fix the charger for him in a few minutes. Okay. So now there are different ways of collecting data of pressure. One of the ways is to do an experiment over time. So, for example, if you were doing an experiment where you were cooling a container full of gas down and you were reading the pressure over time, this would be fine. But what we're going to do is we are going to change something else. Now, this is a syringe, ladies and gentlemen. What is this going to allow us to change about the gas inside of it? The volume. It also could allow us to change the amount of gas. Because right now, if you pull the syringe out, you will be putting more gas inside there. If you push it forward, you will be getting rid of that gas. But in a minute, we're going to hook this up to our pressure sensor, and then the amount of gas will not be able to change. So we are going to do our event, ladies and gentlemen, is going to be different volumes. So up here, click on the drop-down menu and then hit event-based. Okay? Then hit event-based. Thank you. Now, you could jump in with any of the three groups you want for the experiment today. Okay? All right. Now, with the event-based, it wants to know what the event is. Our event is going to be a certain volume. So I'm going to type in volume under event name, and then the units for volume is going to be milliliters, lowercase m, capital L. And then we are going to hit done. So change to event-based, change the event name to volume, change the unit to milliliters. When you are done with that, hit done. Is there anyone who needs more time? Okay. Now, it does a couple things. One, it made our graph smaller. It put volume down on the bottom instead of time. And it created a data table for us over here that has volume and pressure. Okay? Now, want to do one other thing because I want you to see what is happening to pressure as we do this experiment. Up in this corner up here, ladies and gentlemen, this square that has the three smaller rectangles or squares in it, two squares and a rectangle. If you click on that, we can then click on a meter so we can see what the pressure is reading now. And then I'm going to go where this bar is here, ladies and gentlemen, and I'm going to lower this down just so that I can see all of the data points on my table. Okay? Questions? All right. Now, if you would just give me your attention. Don't worry about anything on your computers right now. Give me your attention. I will go over things, and then we'll get you going. Okay? Now, the one thing you can do is you can grab your syringe, ladies and gentlemen. Okay? Now, if you look at your syringe, you're going to see two lines that are kind of brighter on the outside of the container. Those are the two seals that we have. Now, those are going to be used to measure the volume inside the container, but they're in two different spots. Normally, I choose to use the top one, the one that is closest to the cone. But here's what I would tell you. I don't care which one you choose to use, but you need to be consistent. So if you're going to use the bottom one instead of the top one, that's fine, but every time we read a measurement, you need to read it to where that bottom one is. If you want to use the top one, that's fine, but every time we read a measurement, you're going to need to read it to the top one. And what I want you to do right now is set it so that either one of those lines is right at the 60 mark on your syringe. Right at the 60 mark on your syringe. Now again, if I move this in or out, I'm changing the amount of gas in there. Okay? So we want to start with it at 60. Questions? Okay. Now, I'm going to ask you to do this, and then I'm going to ask you to put this down. To hook it up to your pressure sensor, you take the ends and put them together, and then you gently turn it clockwise because it actually screws onto the sensor. Please do that now. Okay? Now, I am asking you, as nicely as I can, this part right here is the weakest part of this connection. And I have seen people hold this and push down on here, and because it gets so hard that they break it, literally will break it off from there. So when we are changing the volume in a few minutes, please make sure you are holding this portion and pushing in this portion. Or you can even use the table. But don't hold it up here and push down on it, because if you for some reason kink it, it will break right in here and then this sensor is shot. I can't do anything because I can't get the new parts.
Can we hold it sideways?
You can hold it sideways, but what I'm saying is hold just the syringe, not this. I had somebody today was holding this up against their body. Don't do that. The main thing is I just need you to hold down here, because if you shake or whatever here, this is going to be fine. But if you're holding this and you twist this way for some reason, it will break right up here. Okay? So now you can set this down for a minute, ladies and gentlemen, and you can watch what I'm going to show you how to do. And then in a minute, we will go do this. Okay? Now, hopefully, ladies and gentlemen, your partner has opened up the lab, and there are two files for the lab. There is the actual document, and then there is a Google Sheet. Why? Because we are going to graph things here. Okay? So the Google Sheet, ladies and gentlemen, looks like this when you open it up. And it actually has a couple of graphs already ready to be made as soon as you plug in your numbers. We'll get to that in a minute. And then there is the lab, which has a spot where you can record the pressure at different volumes. And that's what we are going to be doing. That's what we're using the pressure probe for. Okay? So eventually, Lakavian, who maybe has the Vernier software up on his, is going to have to get the information from Jeremiah and put it in his. And you're going to have to put it in here because that's part of your lab. But then you're also going to have to put it into this Boyle's Law Google Sheet, because that is what will be doing the graphing for us. Questions? Okay, good. So, ladies and gentlemen, here's how it works, though. When you're ready, you're going to hit the collect button. Now, when you hit the collect button, don't worry. It doesn't actually start collecting data because we're in an event-based mode. So what you're then going to do is one person is going to take and adjust the volume of the syringe until you get down to 50. And when you get down to 50, ladies and gentlemen, and you have that, then you are going to hit this keep button. Please don't do it now. Listen, watch, pay attention. Now, as soon as you hit the keep button, you can let go of this. You do not need to keep it pushed in, okay? What it did is it read the pressure at that volume, but now it doesn't know what volume you were at. You have to literally tell it what the volume was. So you're going to type in 50 and hit enter. Now it's ready to do it again. It did plot the point. Here's 50. Here it is. Was around 117. Plotted the point for us. Now we're going to go down to 45. And when I get there, again, once I'm right on it, I go keep. And now I can let go of this, relaxing a little bit, and go 45. Now the hard part is you need to get down all the way to what volume, according to the lab? 20. It is going to become more difficult as you do that. If you find that you're struggling to hold this in place and you can't hold it and then hit the keep button, have your partner, when you're ready, you can be like, all right, I'm at 20, hit it, hit it, hit it. And if they're mean, they're going to be like, are you ready? Are you ready? Are you ready? And you're going to be like, yeah, hit the dang thing. Yeah, you two, talking to you. I can see this already happening, okay? So what you need to do is you need to collect all your numbers down to 20. 50, 45, 40, 35, 30, going down by 5 every time. Once you have all your numbers in here, ladies and gentlemen, you can hit stop. You don't have to, but you can hit stop. You'll have all your numbers here. Now you go to your partner and you're being like, all right, I'm going to type them in here, both people, and then I'm going to type them in here as well, okay? And that's what you need to get done in the lab. Once you're done with that, you can take this apart, bring me back the sensor and the go link, hold on to the syringe for a few minutes, okay? And if you're done early, you just got to wait for everybody to finish up. So go to one of the many stations we have in back, since there's only 3 groups today. Go to one of them and get your data collected, please.
Can we stay here?
If you wanted to, you could stay there. I don't care. If you need more room, go ahead and get more room. This should not take long, ladies and gentlemen, but please make sure you are trying to be as accurate with your volumes as you can be. Better data means better results.
Oh, you have to do it like, you can just do it after.
It is absolutely okay to let go of the syringe, but you have to hold on to the volume until they hit that keep button. Once they hit the keep button, then you can let go. Okay.
We accidentally hit keep.
Hit
Does it matter which one? Do that again.
the 3 dots there. You're missing them. They're really hard to see. Come this way, just. Oh, sorry. It stopped. Never mind. I couldn't. It did that to me earlier. Now hit the 3 dots and hit delete data set.
See,
Yes.
I knew you was a bad teammate.
And then you don't want to delete that one too.
No, you could use it. It'll show up there. It doesn't matter that it's set to. So now you hit collect, and then when you're ready, you start collecting.
Okay, you want theirs?
All right.
Huh? You can lower the brakes.
How we doing?
Oh, okay. Doesn't bother me. Okay.
We good? Questions? 50. Okay.
I
So
didn't
now
know
go
to
down to
back.
40.
Okay. No, it's okay.
When you go down to 40,
So bear with me.
you keep.
So
And if
my brain's
somebody-
gonna be a
if
little
somebody
slow.
hit you when it's at 40,
Okay.
you don't have to do all of it on your own.
45.
Then go down to 35, and then 30 all the way down to 20.
I think it's actually 30. Oh god, so it's great.
No. You're putting pressures in there, not volume. Pressures are these numbers over here.
Okay.
You just told him to hit 50 and 45. He's typing in the same number that's in the first column.
No, I said 50, that's 45. Yeah.
He was asking you for the pressures. You were giving him the volume.
I thought you knew what this. The numbers never changed.
He can't see them. They're way away from you where you are, and they're small. Okay.
If you want me to do
Go.
harder
Yeah.
ones, that's cool because I got big arms. It might be a thing. If you are struggling, good. What's that? I'm gonna try to do it as quick as possible. Okay. And the big one. Yeah, I'm gonna use the other hand. 20. There you go. Cool. I had music before somebody. Oh. Alright. Orchestra kid or event kid? Yes.
Okay. Now that you got your numbers collected, make sure you both get them into both the lab sheet and the data sheet, please.
So, here, do you want to just copy off of this?
Yeah, and then you
take
can
yours. Perfect. I'll just copy it off of yours. And then just paste it all in.
You could be able to drive home.
Huh?
You could be able to drive home.
I actually don't drive. Okay. I drive like I only can really drive with the instructor kind of thing in my town right now. I have like 2 more lessons. 3 after today. After today, that's 3 more lessons, and then the big bad test.
Oh, okay.
And then I'm good, and then I can drive on my own, which I actually can't wait for because that would be so much more convenient. Because my boyfriend came to work extremely late. Like he goes to work at like 4 hours after he picks me up. And then he works until like midnight, and then comes home, stays up and plays games until like 2 a.m. Only to get up at 6, 7 a.m. to bring me to school. Yeah. And then he sleeps the rest of the day while I'm here. So. And like some mornings, that's honestly like it'll be honestly why I'm so late is because like I can't get them up.
All right, make sure everybody in your group, once you're done with your numbers, gets all of the information in both their Google Sheet and in their Google document for the lab. You need it in both.
And so I'll have to be like trying to work on him and constantly checking if he's still waking up while also getting myself ready, which is immense amounts of stress at 6 a.m. in the morning. And then I'm never here on time ever, and then it makes like my first hour teacher always hate me, and I'm like, I'm sorry, I live on the west side. They run a train, a boat, right at 7 in the morning, and then I gotta rely on somebody else to give me a ride here who sleeps because they work until midnight. So they're like, oh, we'll take the bus. It's either I get here at 8:20 or 6:20 then.
Yeah.
You gotta get it right there.
I don't want to arrive here at 6:20 in the morning.
Why I do, it's nice and quiet. Nobody's around. It's great time. Great time.
Okay, but I still don't.
There we go.
Well, we all have to make choices.
But also I have to wake up even earlier than 2 a.m. I'm not excited for that.
You wake up at 2 a.m. to be out of the house at 6 a.m.?
Yep.
That's interesting.
I have a lot of prep time.
What? Oh, yeah.
Just gotta have a lot of mental prep
How is it the same person?
to deal with it.
No, it is on your own. I know it is on your own.
And plus that I can have my time eating and doing my makeup, hair. And any other unexpected thing that happens to happen in the morning. Like that one morning when my dad's Spotify wouldn't work, so I had to stop my entire morning routine to fix his Spotify for him. Yeah. He's 56. And he's just switched from flip phone to smartphone.
It's the same.
So I'm a Best Buy worker right now. Like oh my gosh. I'm surprised he hasn't thrown that thing across the room. I've been kind of waiting for him to. The thing is, he has the exact same phone as mine.
Hello, sir.
I was looking at this all day, and I have it past this right now.
From who?
No, she's gonna give it to attendance. I don't know her name, but yeah.
Okay.
So you know, I'm not a bad player. We do.
Well, you weren't where you're supposed to be.
I mean, what many more years until it's happening?
What's that, sir?
The solar eclipse will happen in another 20 years.
So why couldn't you cut it then?
It'll be 38. 37.
There's no age limit on eclipses.
He could die before he turns 38.
Could die before he turns 18.
You're just anti-eclipse. Are you an anti-eclipser?
I just don't think it's that big a deal. It happens all the time. So
Once every 20 years. That's kind of cool. That's special.
so does my 20th birthday. So does my 40th birthday. So does my 60th birthday. Right?
Well, that makes it special.
Why?
That's what I'm saying. I thought I seen it.
Why is that any more special than your first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, tenth birthday?
Every birthday is special. You're celebrating another year of you being alive and not being stupid enough to die.
It happens every 20 years.
Exactly every 20 years.
Not exactly, but it's approximately every 20 years. They can tell you exactly when the next one will happen. I just
That's why it's been
Gotta include leap years and stuff.
probably wasn't in your lifetime if it's every 20 years.
Wait, I
Hey.
think there was another eclipse that happened.
You guys get done? Come on back. Bring up the pressure probe and the GoPro. And when you go back to your desk, take one of these blue things with you, please. Come on, let's go. Get all of your information, ladies and gentlemen.
So you could just copy this.
Yeah, go to the
What?
You want us to relabel the axes of the chart?
We're going to talk about that, yes. Yes, yes, definitely. All right. Okay, so these numbers should now be filled in for you, ladies and gentlemen. These numbers should also be filled in, and if it looks kind of like my numbers, that is absolutely fine. I did not, I measured these earlier today, so your numbers should be fairly close to mine, but not exact. All right, let's begin with this. What is happening to volume in this table? Decreasing. What is happening to pressure?
Increasing.
What kind of relationship is that?
Indirect.
You're close. Inverse, not indirect. We use inverse. That means that as one thing is going up, what is the other doing?
Down.
Going down. The other is going down. Ooh, Hassan. We need to get you next door and take this quiz real quick. The quiz from Friday, the one you missed. Grab a periodic table if you want it for notes. Grab your pencil and your calculator.
Yeah. You just have to change the X and Y axis and then go to edit charts. Customize
You know what? Snap out of it. What would you say if you seen one down?
chart in axis titles.
This one you're not smart on the court.
Chart title. And then that'll be
Where it starts is the classroom. Where it starts when you wake up, when you go to sleep. What time you go to sleep? Not on time. So that's what you did. Your day was messed up from the point you went to sleep at 1.
All right.
Like that.
Now,
Just saying.
when you look at your numbers, what do you notice that looks strange? Nope. They are all decimals, and I guess it may look a little weird, but psst, Tweedledee, Tweedledoo, please pay attention. What do you notice about your numbers?
And then that's pressure, right? Okay. That they are.
The numbers are like, they're going down.
No.
Which numbers are going down, sir?
Oh, I thought you were talking about the KPA pressure ones over there on the far right.
Nope. Talking about the numbers you collected. What's unusual about them?
Increasing?
They are increasing, but that's okay. Look more closely at each number compared to the next one.
They
are like exponential because they keep jumping.
Okay, they're not going up by like the same amount each time. Okay, I got that. Yep, good call. Good call.
The 25 and 20 are the same.
25 and 20 are the same.
On yours.
What are they on yours?
Okay, I thought that was weird because okay.
Well, I'm glad you pointed it out when I asked you, what do you notice about your numbers? Well, that was weird, but I didn't want to say anything because it was weird.
Oh yeah.
Okay, so what I would like you to do, ladies and gentlemen, is take your syringe, set it for 60 again. Put the cap, well, if you put the cap on, yes, take it off. Otherwise, you're not going to be able to set it for 60. Put the other cap onto it. Okay? And now what I want you to do is, if you were the one who was doing the pushing before, have someone else do this now. Okay? But what I want you to do is I want you to... Oh, sorry. There you go.
Wait, we didn't have a good one.
He's got the cap right there.
I've never seen it. Yeah.
Well, I understand that. What I want you to do is push it after you put the cap on and you screw it on. Push it so that you go down to 25. Notice about how hard it is to get it to 25. Let it go. And now I want you to push it down to 20. And tell me, is it harder to get to 25 or to 20? 20?
20?
20?
20's pretty hard.
Only slightly though.
Dude, I've never seen anybody pop the cap off there. You're either incredibly strong on pushing or incredibly weak on putting the cap on. Is it possible for these two numbers to be the same, ladies and gentlemen?
No.
It's actually harder to go down to 20 than it is to 25. Why are those numbers the same then? What's a possible explanation?
Since it slightly doesn't change.
No, it's a pretty good,
That's
pretty,
cool.
it's a harder difference. Anybody?
Is it because it's higher up on the syringe?
Nope. Oh.
It's because you're like pressing the air down to a certain point where like it can't really go anywhere.
Yeah, but then it wouldn't be harder to press it down to that 20 than it is to go to the 25. How long is this?
A meter.
1 meter. What's the problem?
It
Too
doesn't go all
short.
the way up to the door. Like
Why?
Because
It's
the
not
door is
tall
longer than a meter.
Okay, the door is bigger than the meter stick, right?
Yeah.
Why are those two numbers the same?
The amount of force.
It takes more force to get there.
This one here is the same as that one because the pressure sensor won't go up any higher than 231.9. We maxed it out. It will not go any higher than that pressure. That's why it's the same as the one next to it. You have pushed
So
as
if I
much
tried-
pressure as that sensor can hold.
So if I tried to push it to 15, would it? Anything?
It wouldn't go up anymore. It would be the same number. You'd
Yeah.
go down to 15, you'd go down to 10, you'd go down to 5, you'd go down to 2. It's not going to change.
Can I try it?
Go for it.
I want to see my strengths.
I don't know how you're going to measure the pressure with no pressure probe hooked up to it, but okay, go ahead. Okay,
That's a little hard.
good. Bring them and put them up here, ladies and gentlemen. So the first thing that we need to do, ladies and gentlemen, is erase that point. Get rid of it. It's not good.
25?
The last
Did I erase the 25?
Not yet.
Which one did I erase?
20.
I erased the 20. Okay? Now, we got to check and make sure that the 25 point is good. Here's what I mean by that, ladies and gentlemen. We are going to take a look at what is the change from $50 to $45. What is the change in pressure? From 119 to 130, how much does it go up?
What if my numbers aren't exactly like yours?
You're going to subtract them just like I'm doing, but let's just look at mine for a minute. What do we notice is the change from here to here? How much? About. Don't go to decimal points, just whole numbers. 119 to 130, how much is the difference? 11. From 130 to 149, how much is the difference?
19.
From 149 to 169, how much is the difference?
20.
From 169 to 196, what is the difference?
23. I don't know.
From 196 to 231, what is the difference?
I can't do that in my head.
Is it 40?
About 36.
Okay.
So, what is happening to our volume each time, Sabrina? What's our volume changing by? 5. Same time, same thing every time? Yes. Is our pressure changing by the same number every time?
No.
No.
Non-constant.
That means that it is a non-constant relationship. So what kind of line would we expect to see for a non-constant relationship? What kind of line would we expect to see for an inverse? Oops, sorry. What shape is that line?
Whoa.
Sort of curved.
Not a huge curve, but can we agree it's not straight?
Yeah. I mean, unless your head's like this.
It's not straight.
Unless your head's at a certain angle.
That's straight, right?
Yep.
Yeah.
Is that straight?
Totally.
No.
Looks pretty.
Is it going up or down?
Down.
Going down. Inverse and a non-constant relationship. Inverse and a non-constant relationship. Now, you need to make a couple of changes to this right away, ladies and gentlemen. You need to take and change the axes on this particular graph, and I'm going to show you how to do that. Go to Edit Chart, and by the way, there is more than one way of doing this. But you need to follow through right now, and if you don't get something, you need to raise your hand and say, Mr. Brand, come over here and check mine. So you're going to hit Edit Chart, and you're going to go to the Customize button. So Customize should be highlighted, and there should be a line underneath it. This then allows you to go and change the chart and axis titles. You may not be seeing it. You may be too far down, but it is the second one down, chart and axis titles. Now we're good with the title on this one, volume versus pressure. But what we do need to change is the X and Y axis values, the label and the unit on them. So if you go to this box where it says chart title and hit that drop down menu, it will allow you to change the horizontal axis title. So let's do that. Horizontal axis title. So now, ladies and gentlemen, you are going to take, and in the box where it says title text, you are going to change axis title to the variable that we control, because you always put the independent variable on the x-axis. What variable did you control in the experiment? You controlled the pressure? You set the pressure.
Volume in milliliters.
We control the volume. You push the syringe in until you got to a certain volume, correct? That's what you were controlling. So this axis needs to change from axis title to volume right now, ladies and gentlemen. And what unit? Milliliters. Change it both. I'm not changing mine. You need to change yours. So this axis, when you're done, should read volume, parentheses, milliliters. And if you don't understand how to change it, right now is when you raise your hand and call me over. Please remember, you need to put the title, which is volume, and the unit in parentheses, which is milliliters. That tells me what these numbers mean. Questions? Okay. When you are done, go back up to the drop-down menu here and choose the vertical axis title. And this is going to change the y-axis. Now, y-axis is the dependent variable. Because you changed the volume, what changed because of that? The pressure did. So in here, for axis title, you are going to type in pressure. What is the unit that we measured pressure in? kPa. So pressure becomes kPa.
Little K, big P.
Little k, and I've seen capital K for kilo as well.
Oh, I
so you could do capital K, capital P, but the P does need to be capitalized. Yes, absolutely.
I always forget which ones are capital.
Absolutely.
Lowercase, so I always just say it just to have it up there.
Absolutely. All right.
Sometimes it helps to say that one.
Questions? Help needed. Okay, so now we can move on. This graph should be done now. If you have updated the axis titles and units, that's all you need to do to this graph. Now go back to the data table. Now, I'm not expecting you to know when to do this or why I did this, but I am going to explain to you what I did and how I did. I made a third column here, ladies and gentlemen. And my third column is 1/pressure. What does that mean?
1 divided by pressure.
Which is called the what of a number. In math, it starts with an R.
The reciprocal?
The reciprocal. This is a little trick that we do in science. This is an inverse relationship. One is going down, one is going up. We hate inverse relationships. They exist, but we hate graphing them. So we are going to take and we are going to use the reciprocal of pressure, because now what is happening to these numbers?
Those are going down
Those are going down.
with the volume.
Well, the volume is going down, meaning it's what kind of relationship? Direct. And you know what would be awesome is if it were direct and constant. What?
Mine curved.
This one did?
Yeah. Well, like slightly.
I can live with slightly.
Okay.
I can live with slightly because this red line on here, this is called the best fit straight line. The computer automatically does it for me. Okay, yours I don't have set to do this, but mine it does. But look at all the points. Are they dead in the center of that line? No, but they are within it, correct? And that's what your computer does. The last one was not supposed to be a straight line. It was not. This one is, which means this is a constant. Now, the nice part about having a constant line and a direct relationship is you know the formula for that line. What is it?
Formula of that line.
Of any straight, direct relationship. Y equals mx plus b. Y equals mx plus b. What is m?
Slope.
What is slope?
Like rate of change.
Rise
Overrun.
Overrun.
Which is a triangle.
Which is the rate of change. We can put triangle in front, change in rise over change in. I understand that. Good. So it's something we're all familiar with, right?
Math class.
What kind of line is this?
Straight.
What does that mean for your slope?
It's a positive constant slope. Or it doesn't.
It is a constant. A constant is a number that does not what? Change. What that means, ladies and gentlemen, is if I wanted to, I could find this point over here. Because the slope never changes. I could find this point over here.
Whoa.
I could project this in either direction. You know how we couldn't find 20? We can with a straight line. We can figure out what it should have been. We're not going to, but we could. Go. And again, this is the part where I say you didn't listen. Take out the 20, which we know is not a good point, and you will be amazed how much straighter your line will look if you still have that 20 in here. Where he had the 20, ladies and gentlemen, was in this table. If you don't get rid of that 20, it's going to affect your line. Is it a little bit straighter now? Yeah. Good. Good. That's why we asked you to take this out. This point we knew wasn't good.
Can you put that back up so we can
Hold on. I'm getting there. I'm getting there. I'm getting there. Okay. So now, ladies and gentlemen, now we need to again change our labels because they are not correct. So, customize, or I'm sorry, edit chart. Get rid of this because otherwise it may be in the way. I don't know. Edit chart. Customize. Chart and axis titles. Let's start with the horizontal axis title. So, if we go on the horizontal axis and go into the box underneath, what is on the x-axis still? Volume in milliliters. So we do volume in milliliters. Okay? We don't need the equation. Don't worry about the equation.
Oh, okay.
I just was showing you the equation to show you that it was in fact the straight line, and we can get that.
I was talking about the little pressure, like
Hold on.
thing on the top.
Hold on. Hold on. Hold on.
Still milliliters?
Milliliters, yes. Still milliliters, yes. Now we need to do the vertical axis. Now your vertical axis is not pressure. It is what? .00250, .00500, .00750. These numbers are the what?
Reciprocal of pressure.
Reciprocal of pressure. Now the way we write that, or the way we show that, is 1 divided by pressure. So 1 divided by the backslash or divided by symbol pressure. Do not put pressure down. I will mark it wrong. It is not pressure. It is 1 divided by pressure. And the unit is not kPa. The unit is now 1 divided by KPA or 1 backslash KPA. So make sure you get these correct.
Chart title.
Now, chart title, hang on a second, let some people get caught up. Yes, Sabrina. Correct. 1 divided by KPA. Perfect. Perfect. Now, anyone need more time? Okay. So now our title, ladies and gentlemen. So now we come up here. We're going to do chart title. We didn't have to do it on the last one, but we're going to do it on this one. For your title, we use the variable on the x-axis, which is what? Volume, versus the variable on the y-axis, which is 1 divided by pressure. So that should be the title of our graph. The variable on the x-axis versus the variable on the y-axis, and you do not need to put units with this. Okay? The only reason we use units is because it's telling us what the numbers represent. Up at the top, the title is just this versus this. Questions? All righty. Now, when you are done with your graph completely, you will come up to the top and you will hit copy chart. Go ahead.
How did you get the other stuff that you have on there?
How did I get what other stuff?
The thing.
You don't need that.
Okay.
You don't need that.
Okay.
I just did that to show you what you could do with this stuff.
Okay.
Now, again, the advantage of the formula is to make predictions for pressures and volumes that are not on here. We're not going to be doing that. Okay? But it could be done. Okay? So, again, when you have your graph done, go up to hit copy chart. Now go back into your lab report. In your lab report on the 3rd page, it says pressure or volume versus pressure graph. Click on where it says no data and delete that. And then you do, then hit Control V to paste in your new table. So you're going to paste in your new table here. You're going to go on to the next page and you are going to paste in your new table there for volume versus 1 over pressure. So in here again, you're going to click on this no data, delete it, and then you will bring in the other graph from your Google Sheet. Copy chart, bring it in, Control V. Questions? That is where we are going to stop today, ladies and gentlemen, because that's how far I got with my last class. Yes.
I'm gonna be gone tomorrow, so can we go like after school for a little bit?
Certainly. Well, I'm sorry, I can't today because I have a meeting right after school. But basically now you are just looking at the questions.
I can send you.
So graph 1 or graph 2. The other thing is I will talk a little bit about this tomorrow, Jace. You could always go to the video and watch just the start of the video from tomorrow's class. But I think you also might be able to figure out inverse or direct for graph 1 and 2. Okay. And then what to do with the rest of them because they're kind of self-explanatory. If not, I can help you on Wednesday because it's still not due till Wednesday. Okay. All right. Questions, ladies and gentlemen? All right, so that should be what you need to do to get it done, ladies and gentlemen. And tomorrow we will look at these questions and we will look at the graphs that go with them. Okay? Real important before you leave today. You should be able to have your 2 graphs in here. Here and here. By the way, 4 points on the graph. The points come from the titles and the labels. The points come from you changing the title, you putting your labels and units on the X and Y axis. You forget something, I'm going to take off for it. You don't put the graph in here, you don't get any points. Okay? That should all be done. I have asked. No one said they needed help with anything. That should be done. Same thing for this one. Title at the top. X and Y axis both have labels and units, or you don't get 4 points for it. Tomorrow we will talk about the questions. This table should be done, ladies and gentlemen. 2 points. All of your numbers should be in there. If they are not, you're not getting the points. Questions? Okay. That's what I got for you for today, ladies and gentlemen.
I did the calculations and it doesn't look right. Because they're not like.
Okay, so you're in. Read the next question.
Yeah, I did, but like I just didn't think they looked right.
Well, they are what they are.
Okay.
And I would have hoped they would have come out better, but they are what they are, and we got to use what we got. Okay?
So answer based on what I have.
Correct. All we can ever do in the lab is base it off of the numbers that, or the information we collected. It may be what we want it to be. It may not be. That's for debate later on. All we can do is tell you, hey, look, according to the lab, here's what happened. These numbers go up. These numbers go down. Maybe they weren't supposed to, but that's what they're doing on mine. Okay? All right. Good, ladies and gentlemen. Good.
Sorry, my phone's somewhere.
Why you care about my next You ain't gonna see it. I'm looking to the ball. I'm already losing here. I feel like one night. I know.